Okay, so what you see in front of me here are my Stellar Labs Club Series CS8 professional passive loudspeakers. Now, I just made a video on changing the waveguides in the CS12s here, and that was pretty successful, but now I've got some orders of business to do with these CS8s. So, one of the biggest problems with these cabinets is that the crossovers that were put in them were not designed quite properly. The crossover frequency, specifically for the tweeter, is really too high. They claim they have 2.5 kilohertz crossovers in them, but I don't believe that for a second, since I've already done the 12s and the 10s here, and changing them to proper 2.5 kilohertz crossovers has made a world of a difference. So I figured I'd document the process for the 8-inch speakers since I haven't done them yet. I've got the grill removed on one of them, so you can see what they look like. Now, these are very interesting speakers. Both the 8s and the 10s have these square waveguides, and these are actually differential dispersion waveguides, which means the coverage pattern varies. As you can see, it's different on the bottom versus the top. And I believe the coverage pattern on the bottom is wider than the top, if I'm not mistaken. But I could be wrong about that. So yeah, these horns sound pretty good, as is. Unfortunately, the horns in the 12s are not differential dispersion and don't sound quite as good. But here they are. They sound really great. And the woofers, specifically in the 8 inches, look a lot like home audio, you might notice, but except for the rubber high-roll surround on these, they're basically pro audio woofers. The 10-inch models have proper woofers that look like the 12s with the ribbed surrounds and whatnot. But these are really cool speakers, though. They're small, they're rugged, as you can see, solid Duratex rubberized coating material, whatever you want to call it. And yeah, the price I got these for, like I said in my last video, was insane. It was $25 each for the 2 of these, $35 each for the 10-inch, and $45 each for the 12s. Like I mentioned before, these are made by a company, or were made by a company called MCM Electronics. And at the time I bought these, they were not going out of business, but they were clearing out a bunch of their inventory in their warehouse because they were merging with a company called Newark. And so they were selling items like these on crazy liquidation deals. Like, it was like something like 75-80% off for these cabinets. So it's great. But unfortunately, the crossovers in these are not quite up to par. So what I've got here are some new crossovers. Now, I've got 4 boxes here. These are Dayton Audio crossovers. These are actually each low-pass and high-pass filters at 2.5 kilohertz. It was actually cheaper to get the separate units than to buy even the components alone or get the full crossover unit. So that's what I did. Here's what they look like. It's pretty simple. It's just in... if I can get it out of here, it's just an inductor and a capacitor. Pretty simple. And they've got spade lug terminals, which is actually nice. They've got 2 of them per side, both on the input and output, which means that I can bridge across from one crossover to the other. And I've got some spade lugs over here. They're mismatched, but they'll do. I don't have any more left. And I'm going to use these to create jumper cables for 2 jumper cables for each speaker. So yeah, I'm going to pull this woofer out of this cabinet. I'm only going to do one cabinet today, and then show you the difference, just like I did with the 12 inches. And yeah, I'm going to pull the woofer out and show you what's going on in there. Okay, so we're now inside the cabinet here. Just taking a little look at this woofer here. You can see it's a very, very nice woofer, actually. Cast steel frame and everything. And yeah, I mean, it's a pro audio woofer with a home audio surround, high roll surround on it. But it's vented on the back. I mean, you can see these are really nice woofers. They're all cast steel frames, just like this one, with the push terminals on the side. So, you know, they're really quite decent woofers. And components in these overall cabinets are obviously built from really nice wood. There's the compression driver down in there, you can see. And here's the crossover that's already in them. First glance, it does look pretty good, actually, like component-wise. But it's just not set. The components are just not the proper values for a 2.5 kilohertz crossover. And interestingly enough, so one thing I just noticed about these 8 inches is here are the crossovers from the 12-inch speakers, and you'll notice these look a lot more bare bones than the ones in here. I'm not sure why that is really, but this one looks it looks like it's missing components, but for some reason this is what was in there, and they definitely intended for that because the label stuck right where that's supposed to be, and it's definitely, well, I guess, I don't know. Either way, it's very strange that they do that. Interestingly enough, these, even though they say M212 on it, this says M208 on there, on all the boards, actually. So, that's kind of an interesting little thing there. But, yeah, so my plan here is actually to take these crossovers out, obviously, and put these new ones in, 2 per speaker, 1 low pass and 1 high pass for each component here. So I'm going to take these out. I'm probably going to use these spade lug leads and solder them onto the speak-on jack, since, as you can tell, the input wires are soldered directly into the crossover. And then I'm going to take the spade lugs that I have, make those little jumper cables to connect to each, and yeah, and then we'll be able to use these. Actually, on second thought, I'm not going to use these because I need these for the woofer. I have the 10-inch crossovers on my messy work or studio desk over there that I'll use for the input terminals so that I can use these for the woofers. So yeah, I'm going to go cut to the next thing of what I'm doing, which will probably be taking that out and soldering the cables on. Okay, so I've detached the back terminal plate now, and here it is. Interesting thing I noticed, these are actually official, genuine Nutric connectors on here, which is shocking. NO4 MPs. I was not actually expecting that from these cabinets, but hey, it's good they're using genuine products in these, like real speak-on connectors from Nutric. So, yeah, that's great. So I guess now I'm going to take the leads and solder them onto the backplate connector thing now, and we'll go from there. Okay, so what I've done now is I've finished soldering the leads on with the spade lugs on them, and so now that that's done, I can proceed with making the little jumper cables that will go from the low pass to the high pass crossover. So I'm gonna go do that and show you what I've done for that. Okay, so I have now finished creating the little jumper cable, as you can see, using some 14 gauge speaker wire that I have lying around. They are the ones that I'll use for the next one. So, all I have to do with this, as you can see, since there's 2 sets of terminals, is go, and I guess I'll use the copper colored wires plus. Go plus, you can't see that, plus, and minus on 1, and go plus, if that would go in, plus and minus on the other. And there we go. Now they're jumped together. Now, I do realize that the old crossovers had resistors in them, and these don't. And both of these, both the Woofer and the tweeter, are 8-ohm components. So that means that the way I'm doing this in parallel, it'll put a 4-ohm load on whatever amp I'm using with them, which, in my case, is okay. The PA amplifiers that I use are rated for 4-ohm loads, so that's not an issue for me at the moment, so that's good. If I want to parallel two of these cabinets together, though, that might get tricky, and I might have to do something about that later. But for now, this is a perfectly fine solution to what I'm doing here. So then all I have to do is pick whichever one. I'll probably do the low-pass filter as the one that will be having the direct input, and I'll just go in with the terminals like that once they're installed in the box, which I guess is the next step ultimately. So that's what I'm gonna do, and yeah, I'll see you once these are mounted in the box some way, somehow. Not really sure, as I can't really get this drill too far into the box without it, stopping and hitting something. So I'll have to figure that out. But I might use the existing screw holes and only do like I don't know. It'll be a little bit challenging, but hey, challenges are good, right? Not gonna progress if you don't challenge yourself. So that's what I'm gonna do now. And yeah, see you when I do that. Okay, so now the crossovers have been installed. You can see the way I kind of mounted these. It's a little bit sketchy, but I've got one screw in each crossover, and they're butted up against this wood brace back here. So they can't come out. They're stuck in there. They'll never get out of there. And yeah, it's not the ideal solution, but it should do for this. And I've ran all the wiring, and got the wires for the woofer and for the horn. And I'm going to put this back together, throw the woofer back in, hook these both up, and I'll do a sound comparison of old versus new. Okay, so I've got the crossovers now obviously installed in the new cabinet over here, and it's back together again. And so I've set up the old cabinet with the stock crossover on the right over here, on the right channel of my amplifier down here. And what I'm going to do is I'm going to fade between the two, and give you a little bit of a sound comparison here, just with the phone microphone, just so you can see roughly what the difference is. It should be pretty clear over this microphone, because it is a very drastic difference. So yeah, and I'm going to be playing a song by Silent Dave called Stated. I've mixed it down to mono so that both speakers will be being fed both channels of the track to eliminate, stereo panning being different and whatnot. So, yeah, here we go, starting with the new speaker on the left. The old. Now back to the new. Now back to the old. Now to the new. Alright, so hopefully you can see from that difference, how much of an improvement the crossovers make in the new cabinet. Not only to the sound quality of the speaker, but to the speaker's efficiency. Because the crossover point is different, and it's lower than that one, it's feeding more frequencies to the high-frequency driver, and it's made the speaker a lot more efficient because of this. as you could hear, I mean, that one was just like 3 times as quiet in comparison. That's just a rough guess. I don't know. I could take my decibel meter out and actually measure it, but it's kind of a moot point. You can hear there's a difference going on here. Yeah. That's basically what the difference is between the two. And how important it is to design a proper crossover for your speaker components, because it can make all the difference in what your speaker sounds like, and how well it performs. I mean, in this situation, that speaker is going to get a lot louder off the same power that one is going to be getting, because it's, the efficiency is greater, and it's going to mean you're going to have a lot more headroom before your amp clips. That was the problem I was having, was I had the old cabinets EQ'd so heavily because of this lack of upper, mid-range, and treble presence that was missing, and in turn the amp started clipping, and I was like, how are these speakers not getting loud enough? Well, that's the reason why. So yeah, that's really about it for this comparison of the two and the whole video in general. I'm going to go do the other cabinet now and actually do the second of those horns. I just uploaded a video about that. Go watch it, for the 12s. So yeah, that's about it for this video. So thanks for watching, and don't forget to like, comment, subscribe, do whatever you have to do, and I'll see you next time.